Okay, let me give you guys another example, but this time we're going to do it properly. What I mean by properly is that in the past I would give you, let's say, a differential equation, it was blah blah blah, and we would get to a stage where we had to find the indefinite integral of something like this, and then so we would somehow get to this stage here, and then when we come to integrate this, I would normally say, oh, by right you should have the absolute value of y here. But then I would keep on saying, oh, let's just keep it simple and just use this. By right, well, I would always say, by right, we should always use this. But let's just keep things simple and use this. So now we are going to do it properly and actually use the absolute value for y. Because for you to integrate this here, it should be this. But then in the past, I kept things simple to illustrate some certain points to you. But by right, you should use this. So in this video, we're going to do it properly. Okay. So let's look at this. Let's just use this as an example here. So to do this one here, times both sides by dx. So that will then give you this. Okay. And then divide both sides by this. That will then take you to here. Okay, and then now integrate equally to both sides, so that will then take you to here. Okay, so once you're here, you have to think, well, for you to find the antiderivative of this, is you trying to think of something that when you differentiate it, it will give you this. Okay, so your guess should be something like this: natural log of something. So your guess should be 3y plus 2. But the thing is, when you differentiate this, it will give you 1 over 3y plus 2. But then you've got to times with the derivative of the bubble itself. It's you using the chain rule. You've got to times it by 3. So when you make this to be your guess, it will give you 3 over 3y plus 2. So for you to get rid of this 3 here, because looking at this here, you need a 1, not a 3. So you need to make the adjustment a third. You see, now if you make this to be, if you differentiate this now, it will give you this. Well, the antiderivative of this is actually a third of this whole thing here. But the thing is, you need the absolute value, and we've done several videos on why you need the absolute value here. Okay, so when you're here, the antiderivative of this should be a third, okay, and you do need that third there, and then the absolute value of whatever was in that bubble there, okay, and then do the same on the right hand side. That would then give you this, okay, and then now times both sides by 3 to get rid of this, so that will then give you this. Okay, so when you times this by 3, you're going to get this, but this is a constant that you don't really care about. Merge your 3 into a new constant. Okay, and then now when you're here, equally to both sides. So it's like this. Okay, so these two will cancel each other out, giving you this, and then this here, when you equals it, well, when you this side, it will become this. But then that would then, remember, x to the power of a plus b, that's the same as x to the power of a times x to the power of b. So that's us doing this thing here. Okay, and then this is a constant. When you it will just give you another constant. So let's just call this to be just one constant, a, capital A. So move that in front. That will then take you to here. Okay. So now when you're here, to get rid of the absolute value here, it will become this. So when you have the absolute value of y equals something here, to get rid of the absolute value, it will be y equals plus or minus whatever here. And I will make some more videos on this part here. So from this stage here, it would take you to this stage here. So to get rid of the absolute value here, you would need plus minus this, and I will make several. I will make some more videos to explain why this is the case. Okay, this is why we kept things simple in the past. When you're here, if you have y, if you have an absolute value of y equals something, then to get rid of the absolute value, you would need to do this. But why is it that? Well, I will make some more videos to explain why this is the case. Okay, but for the time being, just accept it. So from here, it would then take you to here, and then and then and then and then take away 2 from both sides, so that will then give you this, that will then give you this, and then divide both sides by 3, that will then give you this. Okay, but don't forget you've got a constant here, and then you divide by 3, so you can merge these two together into a new constant. So it just looks neater. Just convert this into a b here, a new constant. And then this constant here, you can normally find this constant by looking at the initial condition. So when someone set you a problem, they normally give you an initial condition. You would then use that initial condition to work out this constant. Okay, and then yeah, so this here is your final answer here. An alternative method is, hang on, so right from the start, I gave you this, okay, and then asked you to times both sides by dx. That will then take you to here, and then the old way of doing it would be to divide this over here. That will then take you to here, okay, and then find the indefinite integral here. But an alternative way of doing this. So earlier I've told you how to get. Earlier it was us starting from here, and then that would then take us to here, and then earlier we took this route here. We took this route and then this route here. But now an alternative method is to use this one here. Okay, so when you're here, it might be easier to factor out the 3. So that, yeah, factor out the 3. So hang on, let me just move this across. Bear with me. So an alternative method is to factor out the 3. So we then take you to here. The good thing is that the coefficient of y here is 1, so it becomes easier to integrate. So when you're here, it will then take you to here. So divide both sides by this bubble here. Okay. So when you're here, divide both sides by this. It will then take you here. It would then take you to here. But then the good thing about this is that the coefficient of this is 1, so it becomes easier to integrate. So when you integrate both sides here, this is easier to do. So it becomes this, and then this will become this, and then it's blah blah blah. Okay. So we'll then e equally to both sides. That will then give you this, and then this will then become this, and then to get rid of the absolute sign, you have the plus and minus, which I will explain in the next video. That will then take you to here, and then blah blah. The only thing that's different is that last time we had a different constant, but overall the whole thing here is actually the same. It's just the constant slightly different. Okay.